All right, let us now start with the second method that we've explained. And here we're gonna use 4 layers, yeah? Um, so nothing changes here. We're gonna import the necessary files. We're gonna mount the drive. And here as well, nothing is changing. Yeah, we use ResNet50 as the convolutional base. So where things are changing a little bit is on the um, data augmentation side. Here you can see that we not only rescale here, but here is the wide range of small transformations we can execute on the data set in order to get more data. We don't do augmentation on the validation set, so nothing new here. Batch size is still 20. And let's define these generators using the flow from directory. But here nothing new. We're gonna use directory training 2000 and validation 8000. All right, so the next thing we need to do is to build our model. And here this is gonna be slightly different. Remember, we're using method 2 now. So we're gonna import model layers and optimizers. And the model is gonna be sequential. But here you see that we add the convolutional base as a layer. And the same thing happens with flattening. We use flatten as a layer. Remember, with method 1, we created NumPy arrays as inputs to the dense layers. So here we have our 2 dense layers that we also used in a previous exercise. So in previous exercise, these 2 would be the network. So in this case, we added 2 layers more. Model summary will give us a summary of the model, and we will see this in just a minute. And here it's important that we freeze our convolutional base, yeah, as explained in the video, in previous video, yeah. All right, so let's now use model summary. And let's run this. So here is the model. You've seen here we have 4 layers. And the total number of parameters in this case is almost 37 million. So this explains why this will take longer compared to the other methods. So let's now compile our model and fit it. No surprises here. We use 2 times 10 to the minus 5 as a learning rate, which is slightly lower as we used in the traditional convolution exercise. And now we're gonna fit the model. We're gonna use a 30 epochs because it will already take a while for this to run. So I would definitely not go to 100 epochs in this case. So let's run it. All right, we're done with our 30 epochs. And basically I took the freedom to add these 3 blocks of code that we've added at the end of every exercise to show us the plots. Let us go and take a look at the plot. So here we see that the training accuracy is going to 1, whereas the validation accuracy is basically not going higher than 50%. So definitely this smells like overfitting. If you look at the training loss going to 0, but here you see the validation loss is gonna go skyrocket. So this overfits very early. So I must say that using the ResNet50 convolutional base has not really improved our situation. Yeah, so we barely get over 70%. So let's take note of that.